Okay, in this video we're going to investigate the differences between bar graphs and their close cousins, the histogram. To start out with, let's have some data that we want to work with. Suppose that we gave out a memory test, asked people to kind of give things back, and we scored what results they had. And these are the different scores of each of the participants from that particular test. Well, first thing that I did here was I just went in and typed all these numbers in and created a bar graph where each single number here represented a bar. Well, let's see what happened when I did that. Here you go. Here's my memory test scores. Down here I have every single value. I'm a little obsessive, so notice I did go at least to the trouble of writing my numbers in order from smallest to biggest. 8 was the smallest value out of the list, right there. 96 was the biggest value here. Most of the scores in this list only happened once. There were a couple that happened twice, so that's kind of interesting. But when I look at this table, it's got a lot of weaknesses, one of which is it's all just ones and twos, so we just see lots and lots of data. There's lots of bars, which are confusing to look at. And as you look at our scale down here, even though we're dealing with numbers, the bar graph, the things that we did to make the bar graph actually just treated each of these more like categories than numbers. There's a huge space here, a smaller space in between these numbers, a smaller space in between these, but there's no indication about relative size of values, which makes this kind of a confusing chart and more confusing than helpful. Ideally, we'd like to have some sort of spacing down here so that we could actually see how big the gaps were in between values. But even more than that, we'd like to have fewer bars so that we could actually get a little bit more meaningful of information when we went through there. So let's go back and let's try, instead of having so many bars, where we have each number value representing one bar, let's try to make what we call grouped data. Here's my data test scores again. One way that we can group data together is to create some sort of a tally chart, separating our values into different categories. Before I make my tally chart, the first thing that I like to do is look up here, find the smallest value in the list. In this case, that's the 8. And the biggest value in the list, in this case, that's 96. So when I'm trying to set up my categories, I need to make sure that I can include the smallest value and the biggest value in some category. And then I just want to break it down so that they're evenly spaced. This was what I came up with. This way I've got 10 categories, significantly fewer, so it'll be a little bit more informative than what I looked at before. My category here goes from 0 to 10, so that'll pick up that smallest value of 8. My biggest category goes from 90 to 100, which will pick up that biggest value of 96. So a pretty good little choice set up for here. The next thing that I want to do is to go through and pick a value for each tally, or take each number and put a tally in the chart. So like, for example, 39 is between 30 and 40, so I put that here. Notice I have up to 40, because once we hit 40, we would be in the next category. So that's kind of a normal standard procedure in terms of creating a tally chart. 70 would be in the 70 to 80 category. 60 would be in the one right above it. 75 down here again. 18 is 10 to 20. 23, there's 2 of those in a row, so those go there. And then 26 also ends up there. Another tally for 96 at the bottom. 37. 55, 8, 40 and 48 are both in the same category here, and then 56 is in the one below. 42, 48, 52, 38, 44 turns this one into 5 values now. We have a 59, a 60 just down below it, a 62, 18, 80, 82, and a 36 right here. Now I can go through and just count all my tallies. I have 1 in the first category, 2 in the second category, 3 in the third category, 4 in this one, 5 in the 40 up to 50, and then I have 4 and 3 and 2 and 2 and 1. This is one of those situations when we're dealing with numerical data like this, especially when we're dealing with binned data or grouped data, we really like to create a type of graph that's called a histogram. It's a special type of bar graph, and here's an example of a really nice looking histogram. Notice my numbers down here look more like a number line. They go from 0 up to 100. They're evenly spaced, 0, 10, 20, 30, 40, so all of my scores are down here. Now, as I go up in this direction, I have my frequency, and that's just how many fit into that category. I do lose a little bit of precision because I don't know, was it an 18 or was it a 12, for example, in here. But at least I have a better view, and it's much more informative. I know now that most of my values happened here between 40 and 50, and things were fairly spread out, which is a much better piece of information than what I had in the graph before. Some other nice things that make this a histogram. Notice that my category numbers are put in right on the bar lines. So here between 0 and 10, this area that's filled in correlates with the 0 to 10 category. And then 10 forms the border and 20 forms the border of the next rectangle. And that's the 10 to 20 category. It has a height of 2, and that correlates with my total of 2. It's common accepted procedures. For example, if this goes between 30 and 40, we assume that it includes 30 but does not include 40 because whatever is on the left starts the next category. So 40 would be part of the next rectangle that goes along there. And that's always going to be the case by default unless you set it up or explain it differently in any situation. So this is a histogram. It's very, very pretty, looks really great. I love the number line portion. I love how each of these bars, notice they nestle right up next to each other. So there's no spaces whatsoever in between them. They're great graphs. They're not too bad to sketch by hand, but for some reason they're very difficult to sketch using technology. Most of the programs that are out there allow you to create bar graphs, but do not talk about creating histograms. And the histograms have some of these subtle differences. Here is an example. I used this data and I created it using the closest thing that I could do to make a histogram. If you're in Excel, you can get an add-in to do histograms, but most programs really don't have anything, certainly not by default. So we're kind of stuck with using bar graphs and trying to do the best we can. What I've done here is I've sketched what I would consider a close enough to a histogram to create it. Notice down here in the bottom I have each category labeled as a range. So this first bar represents 0 to 10, the second bar represents 10 to 20, the third bar represents 20 to 30. In Excel you can kind of shrink these gaps so they look kind of small. A lot of programs you can't do that, so you just do the best you can. Here I've got all of these as they move up this direction. I have the number of people this way, or you could label it frequency. Either of those is fine. And we can see that the general shape all looks the same. So while this is down here, this is a perfect histogram. It's the best thing we can do. This is a bar graph made in the style of a histogram, where we have the number line being represented by the categories down across the bottom. How did I make that? Well, I made the graph that I did just by using that NCES website that we talked about in the last video and that you have a link to in the Angel data. This is just in the design, I just picked a bar graph. In the data here, I've got my title, my labels. Notice when I created my categories here, each category that I created actually is written as a range, so that's why they showed up appropriately there on the bar. And then down here, I just have how many people or how many test scores there were for each of those different categories. And that's what gave me this graph here. Again, consistently from 0 up to 100, I've got a space for every value. It's just that it becomes really hard to label. For example, a regular histogram would have this bar labeled as 10. This is 20. Excuse my bad handwriting here. 30, 40, and so on, right on the line. But for some reason, it's just really hard to get almost all programs to do that. So what I've got up here is just the generally accepted practice of what we can do in terms of the graphs. Now, what do you do if there's a gap in the graph? Let's suppose that instead of having 3 values between 20 and 30, let's suppose that my data had no values between 20 and 30. You can kind of see that here. I put a 0 in that category. If you do that, this is what your histogram would, or closest bar graph version of a histogram would actually look like. We have a 20 to 30 category. There's a space for it so that my number line looks consistent, but it's actually empty because it had a frequency of 0. If you're trying to create something as a histogram, you need to make sure that your spacings in between each values are equal, so it's kind of like a number line. So if you end up with some category or some number value with no results, we still want to leave a space for it. That way I can look at this and say, sure, most of my values here are still between 40 and 50. There was a little gap here between 20 and 30, but then there were just a couple values that were smaller than that. And being able to see that gap is very, very useful. So as we're creating bar graphs and histograms, really just think of this bottom scale axis as kind of like a number line, and if there's any holes, we still need to leave a space for them when we create our graphs. With that, I would like you to go ahead and try to create a couple of these histograms on your own. Again, you can just use that NCES website to enter it, just create it as a bar graph, just leave spaces if you have a number or a category that is not filled so that you can get this nice shape for it. And you can try that on your next couple of pieces of homework. Good luck.